Okay, let's have a look at how to factor a sum or difference of cubes using the formula. And the formula is an if-then. Now, what's a formula? A formula is just a pattern that somebody noticed. So it's not something you actually do. It's just a conclusion that you come to, and it lets you skip some steps in there. All right, if you have two cubes with a sum or a plus in the middle, or two cubes with a minus in the middle, then this is the other part of your formula. X plus y times x squared minus xy plus y squared, or x minus y times x squared plus xy plus y squared. Notice, the only difference in the formula is the signs. And there's an acronym, SOAP. You have same, opposite, always, positive. So these two signs are always the same. These signs are always the opposite of whatever was right here, and your last sign is always a plus sign, all right? So in the formula, x to the third, y to the third represents a perfect cube. And in the formula, x and y represents the root of these two. And x squared, y squared represents the square of the root. So first, let's just examine the components of these formulas. If I take the numbers 1, 2, 3, 4, 5, and I want to find their cube, if these are the roots, then I'm going to cube it. 1 to the third power is 1 times 1 times 1, which is 1. 2 cubed is 2 times 2 is 4 times 2 is 8. 3 cubed, 3 times 3 times 3 is 27. 4 cubed is 4 times 4 times 4, 64. And 5 cubed is 5 times 5 times 5, which is 125. Okay, now let's look at some variables. If I have x and I cube it, that's x to the third power. Now if I have x squared and I cube it, what do you do when you have one base with two exponents? If you'll remember, you multiply, okay? X to the second times x to the third, you add exponents. X to the second to the third, you're multiplying. So we're just going to multiply every exponent times 3. All right, here I've got x to the third cubed. Well, 3 times 3 is 9. Here, x to the fourth y cubed is going to be x to the 12th y to the third. All right, now if I take 2a cubed b to the 5th and I cube it all, everything in there has to be cubed. So 2 to the third power, 2 times 2 is 4 times 2 is 8. 8 to the third cubed, a is a to the 9th, and b to the 5th cubed is b to the 15th. Now let's look at fractions. When you cube a fraction, you have to cube numerator and denominator. So if I cube 1/2, well, 1 cubed is 1 and 2 cubed is 8. If I cube 1/3, 1 cubed is 1 and 3 to the third power is 27. Now if I cube 3/5, well, 3 cubed is 27, 5 cubed is 125. Here, cubing the whole thing is going to give me x to the third. 4 cubed is 64. All right, now let's look at this one. Let's be careful. If I cube 2, 2 times 2 is 4 times 2 is 8. Now when I cube x to the third, I'm going to multiply exponents. So that's x to the 9th. All right, when I cube 3, that's 27 y cubed. Okay, let's step through a couple of examples now. A to the third plus 27. So first, do you have two perfect cubes? And yes, you do. As far as variables go, if your exponent is a multiple of 3, 3, 6, 9, 12, then that's a perfect cube. All right. So in your formula, the x now represents the root of x to the third. So my first number is going to be the root of this. The cube root of a is a. All right, now the same thing with y. This y is the cube root of this. So what's the cube root of 27? 3. And once you have your roots picked out, you don't even need to refer back to this to do the rest of your formula. So the next part of my formula says x squared. Well, this was x, so if I square it, that's a squared minus. Now, x times y. Well, here was x and y, so if I multiply them together, I get 3a. And then my last term plus is this number squared. 3 squared is 9. Okay, now let's look at an example of a difference of two cubes. So do we have two cubes? Yes. 8 and 125 are perfect cubes. Anything that has an exponent that is a multiple of 3 is a perfect cube. So we're good to go. All right, the first part of our formula says find the cube root of each of your terms. Well, the cube root of 8 is 2. And when I take the cube root of something with an exponent, I'm just going to divide that exponent by 3. So 6 divided by 3 is a squared. All right, here the cube root of 125 is 5. And the cube root of b to the 9th, divide it by 3, and I get b to the 3rd. Okay, my first term is going to be this squared. So when I square 2a squared, I get 4a to the 4th. My middle term is this one times this. So when I multiply these together, I'm going to get 2 times 5 is 10, a to the 2nd, b to the 3rd. Put your letters in alphabetical order if possible. Okay, and then for my last one, I'm going to square 5b to the 3rd. So that's going to give me 25b to the 6th power. You're good to go. Okay, let's look at example 1. Now, before you use your formula, you always want to look for a greatest common factor. I know that none of the problems we've looked at so far have had one, but you still always look for that first. Then we want to verify that we have a difference of cubes. We have a difference. 1 is a perfect cube. 216 is a perfect cube. And since x has 3 or a multiple of 3 for an exponent, that's also a perfect cube. Now, the first part of our formula says take the cube root of each of your two terms. The cube root of 1 is 1. The cube root of 216 is 6. And the cube root of x to the 3rd is x. Now, like I said before, I don't even need to look back at that anymore because this is built off of these two roots. All right, my first term says take that root and square it. Well, 1 squared is 1. This says multiply the two roots together. So 1 times 6 is 6x. Then for the second one, you're going to take this and square it. So that's going to give you 36x to the 2nd power. Okay, let's look at number 2. Negative 8 minus 27m to the 3rd. Now this one's going to be a little bit trickier as far as the signs go because of this negative number. But we're just going to go slowly. All right. Do I have perfect cubes? Yes, you do. What is the cube root of a negative number? Well, it's a negative number. So my x is now negative 2. All right, minus my y is 3m. Okay. My x was negative 2. When I square that, I get positive 4. So that's fine. Now for this middle term, my x times y, what was x? Well, it was negative 2. And what was y? Well, it was just 3m. This minus was not a part of this. This is just y. So when I do negative 2 times 3m, I get negative 6m. I know that's a little confusing. All right, now we're still going to continue with this sign. And my y squared is 9m squared. Like I said, that one is tricky because of the signs. You don't see a lot of those. So let's move on to number 3. Okay, let's look at number 3. Now, we do have a greatest common factor this time. So what is the greatest common factor between 3m to the 4th and 3m? Well, 3m is. So when I factor that out, what do I have left here? I have m to the 3rd plus 1. And here is your sum of two cubes. So the 3m, we're just going to tag it along. We don't want to lose it. But now we're going to factor this. All right, the cube root of m to the 3rd is m. And the cube root of 1 is 1. I'm using my top formula. All right, when I square this, I get m squared. When I multiply these two together, I get m, and that should be a minus sign. Don't forget, same, opposite, always positive, and 1 squared is 1. So you see how important getting out that greatest common factor was at the beginning. Okay, let's look at number 4, 27m to the 4th plus 125m. And yes, we do need to take out the greatest common factor. There's an m that will come out of both of these. When I divide m from here, that's going to leave me 27m to the 3rd. When I divide m out of there, I'm just left with 125. Now, do you have two perfect squares? Yes, with a plus sign. So we're using our top formula. Now you don't want to lose that m that you've already factored out, so let's bring it along. Now I need the root of both of these numbers. Well, the cube root of 27m to the 3rd is 3m. The cube root of this is 5. Okay, continuing on with my formula, now I want to take that root and square it. So I'm looking at this root squared is 9m squared. All right, for my middle term, minus, I'm going to multiply the two roots together. So 3m times 5 is 15m. Then for my last term, I'm just going to square the 5, which is 25. Okay, let's look at one more. Okay, number 5, m to the 4th minus 8mn cubed. Let's get the greatest common factor out first. There's an m in both of them. So if I divide that out or undistribute it, that's going to leave me with m to the 3rd minus 8n to the 3rd. Now, do you have a difference of two cubes? Yes, you do. 8 is a perfect cube, and both your m and your n have a cube for an exponent. So to factor, to apply the formula, I want to take the cube root of this, which is m. Since this is a difference, I'm using this bottom formula. Minus, all right, the cube root of this is 2n. Now let's go to the rest of our formula. I want to take this first root and square it. So that's going to be m to the 2nd. Now I want to take both roots and multiply them together. So that's going to be plus 2mn. Put your letters in alphabetical order anytime you have more than one. Then my last term is plus this squared, which is 4n to the 2nd. And there you go.